So, hello everyone. As usually, I'm Mustafa. I will not speak Arabic in this lecture in order for the YouTube auto caption to be able to caption my words, of course, so that you will be familiar with the spelling of the words, so it will be easier for you in the exam to write it. I'm trying to tweak my lecture a little bit in technology, so today I'm using a virtual medicine app. Which obviously is much better than any other apps. And it is easier for me to explain because I don't have the materials or laboratory to use. So, in this lecture, I have just got back from my Group D exam. The exam was in four batches, four students enter. All of the questions are the same, except there is a little bit difference, like in the sample from plastic to cadaver, or to you will have a cadaver, like at least one cadaver in your samples, which will have a marker using a strange needle. It have each question. You have two questions, each question with A and B. So you'll need to have a paper, write your name, your group, and to answer the questions. So here I'm not doing a lecture for beginners. If you don't know uh, the exam material, I don't recommend you towards this lecture. After you complete it, either when you are in the college or in your house, you could see the lecture. It will be helpful for you to understand what they examined us with, and I will explain a lot of things in the lecture that it may come to you in the exam. So, first of all, I'm gonna talk about the lung because we had the lung, we examined, we had it in the exam. So I'm gonna delete the skeleton. I don't need it anymore. Uh, they brought us a plastic or a cadaver sample for of the lung, like you see here. Either you have the left or the right lung, they will always point to the oblique fissure because the answers are all the same. So I got the left lung for me, which has only one fissure, which is the oblique fissure. I answered it easily. Other student had the second lung, which is the right lung. They misunderstood the horizontal from the oblique fissure, I think. So they messed it up. And here we can see the which is the oblique or the horizontal fissure. You need to identify the superior lobe of the lung or the upper lobe of the right lung in order to understand which fissure we are talking about. So here you can obviously see the horizontal fissure, which is not, it is obvious, it is not obvious, but here is the oblique fissure. You can see it. The oblique fissures, okay, I need to move from this area. Okay, that's probably better. The oblique fissure is prolongated to the back of the lung and it will rejoin the horizontal fissure here. So mostly the inferior lobe of the lung will appear on posterior side easily than the anterior one. If we want to talk further about the lung, there is only the bronchi. We have a primary bronchi or the main bronchus, either left or right. You can remove them. You can see in there we have the secondary bronchus. The secondary, like this is the main, so the primary, then the secondary, then a tertiary, then the ending, which is the bronchopulmonary segments. And that's so deep, it is, I don't think it will come to the exam, but we talked about it in order to cover it. You can see here we have the pulmonary ligament. I'm marking it with my marker. I could use some drawing if you want to appear better. Function marking. So I'll draw with the red color. That will be easier. Here you could find on my drawing, you could find the pulmonary ligament. Okay, I will clear all drawing. So here, this area, this red area, which is the helium or the root of the lung. Here the parietal viscera will come and then emerges here, then being fold to make the parietal viscera. Sorry, the visceral pleura will come here, and then fold to make the uh, parietal pleura. So this is a pleura, though I think that's the important thing here. We don't need to understand the pleura. It is not important in the exam. So this is a pleura, the white colored. In order to understand the veins here, we need to have the heart. So I'm gonna undo all this. Okay, let's undo it all. Let's bring the heart. We don't need any veins. A little bit. We will really need some of these. Okay, that will be enough. In order to understand the insertions of the veins, the pulmonary vein, the pulmonary artery, and the bronchus, we need to look to the heart first. So I will remove the lobes of the lung. I will remove the lung, the whole of the lung, temporarily, to understand the heart. In the heart, we have here the pulmonary arteries, which if you see, they are coming from the right ventricle, the pulmonary trunk, sorry, the pulmonary trunk here, then giving the pulmonary artery. Like it is going superiorly and then dividing. Can see it here posterior more clear. Here's the trunk. It is dividing to two. The pulmonary, the left and the right pulmonary arteries. They are superiorly. We can see the left atrium, which is if we move the viscous layer of the source membrane, we could see the. Sorry, I need to unmerge it. Here we could see. Sorry. Okay. Here's the posterior wall of the left atrium. Although we need that, here is the left atrium. So this is the blue colored is the veins, which have the oxygenated. Here the veins are colored as the name, not as the blood they carry. So they are colored in a blue color. Sorry about that. That's the order here. So this is pulmonary veins, which have the oxygenated blood. They are coming to the left atrium, so they are more inferior. Let's talk about the bronchus a little bit, so we understand the insertions of it. We don't need the brighter layers. I'm gonna remove the heart. I don't need it anymore. Here we can see the bronchus. It comes more behind. It's behind the heart in the end. So if we take the bronchus, here we can see its insertion just behind. So we can identify these openings now easily. Actually, even without colors or without even structures. So if we take a marker using a red color, I will use the blue color for the pulmonary arteries. So the pulmonary arteries, we said that they are more superior. So these two openings are for the pulmonary artery. They are superior, so that's why. They come from the pulmonary trunk, as we said, from the right atrium, and then they will insert in the lung. If we want to talk about the pulmonary veins, they will come from here, from the light colored area. Sorry, I deleted the blue one by mistake. So this light colored area is opening for the leaving of the pulmonary artery to the left atrium. So that was most of the talk about the lungs that could come in the exam. Can talk a little bit more about the surfaces of the lung. Here is the posterior surface, obviously, and posterior to this is the anterior line and posterior. So this area, take a marker. I need some bends. Okay, I'm gonna remove that when it took a bronchi segment. That's not important. Oh, okay, I will add them in here. This area, which is bent with this bend, is the medial posterior surface, or we could call it a medial vertebral surface also. On this pin, this is the mediastinum area, which have an anterior side, a middle side also, and a posterior side. If we want to talk more about this area, it is a little bit important. We're gonna I'm gonna remove the left lung. Okay, I'm gonna talk only about the right one. So there's some crap here, leave it. Okay, this area have a little bit of curve, groove on my, this the ball, the white ball. Here's the area for the azygous vein. You can see the azygous vein clearly if we add the veins into our model. Okay, here's the azygous vein. It is a little bit far away here, but it comes like this. So you can see obviously here's the azygous vein, which will, let's remove this a little bit. Could see that the azygous vein eventually, if we place it back to its main anatomical position, it is not really that detailed, but there is a groove for him right there, so that when the lung expand, it will not be compressed by the lung. It will insert in the superior vena cava. So obviously we have two areas now. When the lung expands, we have an area for the superior vena cava. In order to make the lung expand in this 3D model, I will expand it like manually. Okay. So if we take it like this, I don't want it to. Okay, it emerged. I don't think we can expand it like normal. So imagine if the lung is expanded. This area, I'm marking it right now, the yellow one, will be the area for the superior vena cava, and the superior area will be the area for the brachiocephalic, or the joining of the brachiocephalic if we be more detailed. So that's all about the right lung. We don't have any more. If we will talk about the pleura, it is not like really hard. We talk about it a lot actually when we talked about the helium, the root of the lung. So back to the forgetting one, the left lung. So yep, this is the left lung. Look, we have like a notch here for the cardiac, the cardiac notch for the cardium for the heart. The end of this notch, I'm marking it with the white ball right now, is called the lingula. Lingula is like a small word for lung, because it is a tongue-like projection, to be honest. So this is the lingula. It is just a projection from the lung after the cardiac notch. So there is a area for the artery, which the descending thoracic artery. If you could see it, yep, it is very clear. It's more clear even than the superior vena cava. Here is the area for him. It will be more obvious on expanded lung. This lung is not expanded; it is in expiration position, so it is not really clear. But there is a groove, a big one actually. Even there is, it is a little bit clear here that there is a groove, arched groove here, for the descending thoracic artery. That's all about the lung. We don't have anything else to talk about. There is also a place for the trachea. It is on the apex. When it's expanded, you can see that the trachea will be in the middle. It won't be compressed. So we could talk. We couldn't talk actually further more about the lung. That's all. So I'm going back to the bones. These are the bones of the thoracic, with the abdomen also added, with some of the upper limb bones, which is the clavicle and the scapula, in order to appreciate how these things are making the upper side of our body, the shape of the upper side of our body. So we will talk a little bit about these bones. So because they are coming to the exam, we will need some cartridges. So we will need connective tissue. These cartridges will help us to make it a little bit easier for you to see. So it is not really detailed in here, but I'm gonna talk about the ribs. We'll talk a typical rib. In exam, my exam, they didn't ask if it's typical or atypical. They only put a marker on the tubercle and asked about it. This is the tubercle. This is the neck. and this is the head with two facets. You can see it is a little bit hollowed. It is not really uh, it is not really realistic in that model, but it is hollowed here. So it have a concave at the end, the costal end. That's all about the ribs. I don't think they will ask you if it is a typical rib. They could, I don't know, but I don't think so. So as you like. They gave us a vertebrae also. I need to take a typical vertebrae, not a atypical. So I need to take like the 6 to the typical vertebra. They add a pointer. I will add you the pointer. I have pointers here also. So function, I need some markings. I will take a pen and mark it like there. It was literally like this. So what will you name it, mister? I think you would name it a superior or supra articular surface or articular facet of the vertebrae. Uh, I got it wrong. I named it a superior articular surface, not a facet. You could name it a facet, or you could name it also a prominent. Either way, you'll take a full mark. Even me, I could take a full mark. I think so. It was only one math exam, so yeah, it was kind of weird for the first time. So that's all about what we took in the exam. Like, let's talk a little bit about the vertebra, then we go to the next question. But about bones, we don't have anymore, like in the exam I took. So here we see a spinous process, and we see a transverse process with an costal articular surface, which which will articulate with the ribs. Here we could see, okay, that's weird. Okay, this is more. We could see here too the superior and inferior demi-facets for articulation with the ribs, the tubercle of the ribs here. And we have a superior articular surface, and which is backwarded. And you can see the other one, the inferior articular surface, more anteriorly. We could have a notch here, an inferior and superior notch on. This is the superior notch. This is the inferior notch. The inferior notch is more larger than the superior, I think. That's what I remember. So that's all about the vertebrae. We talked about the ribs, the vertebrae. I don't think you need me to talk about the sternum. Here's the sternum. It has a menubarium, a body, and the sternum or the xiphoid process. I don't think that's important for you. The first rib is a little bit important. It looks more like a pickaxe, to be honest. Like a real pickaxe. So it has a normal things. It has a head. This is the head with the tubercle, of course. Sorry, where's that? Backing to the model to ensure that I'm right. Yeah, that's the head with the tubercle. Here we have two grooves for the subclavius artery and vein. The subclavius vein is more anteriorly than the subclavius artery, and they are separated by scalenus tuberosity or scalene tuberosity for the attachment of the scalenus anterior muscle. That's all about bones. So we have covered the vertebrae, the ribs, and also the pleura and the lungs. I think that's all about it. We have the muscles. That's what left. So let's talk a little bit about muscles. It is very easy actually. Even in a cadaver. Here we can see obviously and very prominent the pectoralis major. Good. And install it. And the pectoralis minor unimportant. Here we have the external abdominal oblique muscle. It has some of its own fascia or the tendon, which makes an oblique aponeurosis here. It could be see more easier on a cadaver because it will be melted down on the rib cage. We'll remove it. This is the internal abdominal oblique muscle. We don't need to talk even about it. So here we will see the serratus anterior. We'll remove it. Which is the serratus anterior are more superficially, as you saw right now. We only remove the pectoralis major and it appeared. Here we can see the external oblique muscle, external intercostal, sorry, muscle. The external intercostal muscle, their fibers are aligned. How could I will draw it. It will be much easier than talking. Like, here is a muscle. Its fiber will be aligned like, imagine this is the midline, and this is the fibers of the muscle. They are medially, obliquely going down. So if we remove this one, I will stop drawing right now. If we're removing the external intercostal muscle, it is hard to see on a cadaver, to be honest, on our cadavers, not in other cadavers. Here we could see the difference between the external oblique muscle and the internal oblique muscle. Their fibers are aligned laterally. Their fibers are aligned more medially. So that's the main difference if we talk on the plastic model. If we remove the internal intercostal muscle, we will need to remove a lot of things in order to see it from inside. I'm talking about of course, about the internal intercostal, internal innermost, intercostal innermost muscle or innermost intercostal muscle, whatever. So most cadavers, they open the chest, all of the chest. Here we could see also the transversus thoracis, which is the sternocostalus muscle. Here we could see it more easily. The internal, the intercostal innermost muscle, which are on the lateral or on the sides of the rib cage, in the innermost surface. If we add back the internal intercostal muscle, you can see it is also here, but it is not perfectly or entirely uh, not submerged, but hidden by the innermost muscle. You can see it on the central part of the rib cage. From inside, from outside, it is pretty obvious. From inside, it is on the central side more appearing because it is hidden here by the innermost intercostal muscle. So, we have also a small membranes and things, vessels we should talk about. Here we have the diaphragm. It is pretty easy to see. It is an obvious muscle, of course, with its really big central tendon, the musculotendinous part of the diaphragm. The diaphragm is called a phrenic in the Latin or Greek, I don't remember. I think Latin. The phrenic means the diaphragm. So yeah, here we have some subcostal muscles, and they are randomly organized here. So about the vessels, we will talk a little bit about main vessels here. So we add lymphs or lymphatics. Here we have a really main duct, which is called, the thoracic duct. Here is the thoracic duct. It comes from the abdomen. It comes in the opening here. It comes here with the aorta. If we add some arteries on the lowest level, the aorta will be appearing. Oh, sorry. It is still not appearing. Okay, here. It comes with the aorta. Here. It is with the aorta, if you see. If you focus on it. So, this is a main vessel. So, let's talk about veins. The heart is really annoying. I'm gonna remove it. Okay, there are the veins. Here we have the azygous vein. You can see it here. This is the azygous vein with two balls. The azygous vein is penetrating the superior vena cava or joining the superior vena cava for more medical term. So this is a visceral layer of the pericardium. So the azygous have a hemiazygous vein on the other side, which is the left side. You can see it on more detailed sample, which is here. This is the accessory, sorry. I don't know why I couldn't find the. It will be really obvious on a model more than this 3D realistic model. However, it is not really appealing. I'm gonna remove the muscle and the bones, or at least just the muscle and the tissue, in order to see better. It is really hard to find it between all this network of veins. This is the exercise, I guess. Hemiazygous. So, however, I think this is the another name for the hemiazygous vein. There is no other veins here. So this is the hemiazygous vein. They call it, I think they call it another name, which is accessory hemiazygous vein. So I think that's all. This is attachment for muscles. We don't need it. So thank you for watching this small video of mine. The Earth was on the Middle East, like, I don't know, 10-20 minutes ago. Now it is looking at the, I think this the Pacific, I don't know. No, it is Japan. So this is Philippines, but is this Philippines? Couldn't identify. This is Russia. This is China. You could see Korea here. This is Korea, the North and the South Korea. This is Sri Lanka, I think, or this is Sri Lanka, one of them. So that was a little bit of geography with a lot of anatomy. So thank you all for watching. I would like to hear your opinion about this lecture, whether you want it to be all in English in order to have an auto captioned video by YouTube, or do you want it bilingual as usual? So thank you for watching. That was me, Mustafa Ahmed. Mustafa Ahmed. I will tell this in Arabic. So see you later in the next video. 1,000 years, I don't know. So hope best for you in the exam.